In this video, you will learn how water quality is influenced by the natural environment and land use changes. The most important variable to explain the natural water quality in a stream is the type of bedrock and resulting soils in the stream's watershed. That's because the vast majority of water reaching a stream in a forested watershed is infiltrating and moving through the soil and bedrock. The majority of the state is underlain by sandstone and shale bedrock, shown in the gray areas on this map. Streams and water wells in these areas would tend to be slightly more acidic. This bedrock has less calcium and magnesium, so the groundwater would be softer with lower total dissolved solids. Conversely, water coming from the carbonate limestone bedrock areas would be less acidic but much harder. These areas are shown in the light blue on the map. This groundwater will have much higher levels of calcium, magnesium, and total dissolved solids. The quality of water flowing in streams, lakes, springs, or water wells can be easily tested. Common tests include the pH, total dissolved solids, nitrates, alkalinity, and bacteria levels. For streams and ponds, it's also important to test the water temperature and dissolved oxygen concentration, since these are very important for fish and other aquatic life. Simple testing of surface streams and ponds can usually be done with test kits and meters available from many pet stores, pool supply stores, or online suppliers. However, a state-accredited water testing laboratory should be hired if the purpose of the testing is to document water quality before a land use activity, like gas drilling or mining, or if you're testing drinking water. These types of water quality measurements give a good indication of the health of a water body for a specific time. Better measures of the overall health of a stream or pond can be accomplished by measuring aquatic life. One example is electrofishing. This process sends a small current of electricity through the stream to temporarily stun fish and other aquatic life, so it can be collected, identified, and measured before being returned to the water. Measurements of the fish populations can provide useful information about the overall health of the water body, especially if they are monitored over time. Measuring insects is also an effective way to determine the overall health of a stream. Many government agencies utilize this measurement because it's easier, quicker, and less expensive. Both fish and stream insects are considered better overall indicators of stream or pond health in comparison to water quality testing. That's because fish and insects live in the water continuously and incorporate changing conditions that could be missed when collecting a single water sample. There are a variety of land uses that can dramatically change or impair water for drinking or other uses. Activities common to Pennsylvania include agriculture, development, mining, gas drilling, timber harvesting, or industrial sites. Each of these activities can have associated with it unique pollutants that may enter nearby water bodies. For example, mining may cause increased levels of iron, sulfate, and acidity due to the rock that is exposed. While each of these activities usually occur on a local scale, acid rain can affect all forested watersheds, even those in very remote and natural areas of the state. Some of the most acidic rains fall over Pennsylvania. Years of research by Penn State and others have shown that acid rain has dramatically changed the water quality, fish, and aquatic insects in many streams in Pennsylvania, especially those in the northern and western parts of the state. These areas contain the more naturally acidic sandstone and shale bedrock. Most land use changes in a forested watershed start with timber harvesting. Here is a typical annual hydrologic cycle for an undisturbed forest, with about 2/3 of the incoming precipitation being evaporated or transpired, and about 1/3 becoming stream flow. Cutting all the trees has a dramatic impact on this water cycle. Without trees, the cycle is reversed, with the majority of the water now becoming stream flow. This has implications for both the quality and quantity of water in the stream. It is important to keep in mind that this change in the water cycle would be short-lived in the eastern United States. Trees would quickly grow back, and the water cycle would return to normal in less than 3 years. Other land uses also affect water availability. The far left bars show an undisturbed forest, with about 2/3 of the incoming precipitation being evaporated or transpired. Streamflow increases and evapotranspiration decreases as we change the forest by clear cutting and then creating permanent vegetation changes to meadows, crops, or bare soil. Finally, the far right shows a paved watershed where nearly all of the precipitation becomes runoff. These land use changes can have implications for regional climates, since less water would be evaporated and available for precipitation in other watersheds. In addition to the changes in water quantity, timber harvesting can also have dramatic influences on water quality. The disturbance to the soil can result in greater runoff and erosion, which can increase sediment in nearby streams and groundwater. Removal of trees from near the stream can result in greater sunlight reaching the water surface, causing increased stream temperatures. Finally, with little vegetation remaining to use nutrients like nitrogen, there will likely be more nutrients in the stream. This can create downstream problems with excessive nutrients that are a concern to the Chesapeake Bay and other receiving bodies of water.